Welcome to Infi. In this video clip, we will discuss the concept of high side injection, which is HSI, and low side injection, which is LSI. In superheteordyne receiver, we have seen that there is a local oscillator which generates the frequency F4, which is equal to Fs plus IF. This is done so that the incoming signal, which is at station frequency Fs, is down converted to intermediate frequency of IF. So output of the mixer, which needs to be equal to IF, is obtained in the frequency component, which is F4 minus Fs. Now this design of the oscillator and hence the receiver is called high side injection, HSI. There is one more option possible in which I can design the local oscillator. I can make my local oscillator to generate the frequency of Fs minus IF. Now if that is the case, then let us see what happens at the output of the mixer. My output of the mixer has to be equal to intermediate frequency IF. So if F4 is Fs minus IF, then you can easily make out that IF will still be available at the output of the mixer, not in the form of F4 minus Fs this time, but in the form of Fs minus F4. If you see F4 is this time Fs minus IF. So if you replace F4 here with Fs minus IF, Fs will cancel out and minus of minus IF will give you plus IF. So even this design will work. I can have my local oscillator to generate Fs minus IF as its frequency, and output of the mixer, which needs to be intermediate frequency, will now be present at Fs minus F4. So nothing else needs to be changed in the receiver. This design is called low side injection, LSI, for simple reason that oscillator frequency is on higher side to the station frequency, and that's why it is high side injection. So you can see that is because of a plus sign here. And in the second case, oscillator frequency is at lower side of Fs, and hence it is called low side injection. So I hope this point is clear to everyone. Now let us try to understand why we always prefer HSI and we do not prefer LSI. We do not prefer the low side injection. In the entire discussion that we had in superheteordyne receiver, till now we had always considered HSI, in which F4 is Fs plus IF. That is because it has some very good advantages over LSI. Let us discuss that. We have seen that double sideband full carrier AM signal range of carrier frequency is from 540 kilohertz to 1650 kilohertz. That means any station frequency that my receiver will be tuned to will be a frequency from this range, and around that frequency there will be present lower sideband and upper sideband, which will contain my information. So that's the range of the incoming signal frequency Fs, 540 kilohertz to 1650 kilohertz. Now this gives rise to the range over which the local oscillator should generate its frequency. In simple words, I can write that Fs minimum is equal to 540 kilohertz and Fs max is equal to 1650 kilohertz, which means F4 will also have its minimum and maximum values in both the cases. Further, let us see what is the expression of F4 in case of local oscillator. Local oscillator is LC oscillator. So F4 in this case is given as 1 upon 2 pi under root LC. And we have already said that we are not going to vary the inductor because it's difficult to do that. We will vary the capacitor of the LC oscillator, which can be done using devices like varactor diode. So in that case, you can see that my F4 will be related to the capacitor as F4 square equal to 2 pi square into LC. I have just taken the square root on both the sides. Now we can make out that if I want to generate the maximum value of F4, then the value of capacitor in that case should be minimum, because if capacitor is minimum, then F4 is maximum. And And on the other hand, if I want to generate the minimum value of F4 minimum, then this will be equal to 1 upon 2 pi square into LC max, because F4 will be minimum if the capacitor is maximum. That is because F4 and capacitor are inversely proportional to each other.